water and molecule of life. I'll share my screen here. So before we start with the getting into water, I wanted to talk a minute about just the atom itself. And so you have in the atom, you have three particles, subatomic particles: neutron, proton, and electron. And the nucleus has two particles. It has the protons and the neutrons. The proton has a positive charge. The neutron does not have a charge. And orbiting the nucleus are the electrons. They have a negative charge. They have very little mass. If you just to get a size, a sense of the kind of the sizes of the atom, or the different kind of an analogy that would explain what, and if you blew up an atom to the size of a football field, the nucleus would be the size of a marble in that football field. So the nucleus is relatively very small. This photograph makes it look like the marble is, or the nucleus is really large. It's not. It's very, very small, and just because atoms are kind of hard to understand and grasp, there are a lot of marble. I mean, there are a lot of atoms, and these nucleuses are extremely small. So those are some of the particles involved. Again, the electrons have a negative charge, the protons positive, neutrons have a neutral charge. That answers the first 5 questions. The electrons are orbiting the nucleus. And it also answers number 6 too in your review. So there's a lot that you can answer right there from what I just said. The electrons here interact with other electrons from other atoms. So in this case of oxygen, you have 6 electrons in the outer orbit. This is the valence electrons. These are the outer ring and they interact with other electrons. Remember, all atoms want to have 8. They want to have 8 electrons in this outer ring. And so what they'll do, in the case of water or hydrogen has 1 electron, has 1 proton, and it will acquire that electron in this outer ring here, and it will make a water molecule out of the two, by adding on the 2 hydrogen atoms. The next video here kind of or next slide here shows that picture. Here's the hydrogen, and here's the oxygen, and then the hydrogen is giving the oxygen an electron. What that ends up doing is it creates a positive charge for the hydrogen atom, because it, as its proton, which is positive, is exposed, and it gives the electron to the oxygen atom, and that oxygen then becomes more negative. So the oxygen is more negative, the hydrogen is more positive, and the water molecule tends to like to interact with other atoms because it has this hydrogen here would like to have another electron, so it's willing to kind of interact with other atoms, or it can interact with other atoms. Another one of the questions here was the difference between compounds and molecules. Now, if this right here is a water, it's considered a compound. It's also considered a molecule. If you have 2 different atoms, they can be a compound. They can also be a molecule. But if you say had just 2 oxygen here that were next to each other, that would not be a compound. So if it's if it's the same atom, it can be a molecule, but it cannot be a compound if you have the same atom. If you have two different atoms, it can be a compound when they combine. So that's the difference between molecules and compounds. Water is considered, this number 9, water is considered the molecule of life because all living things require water. That's the first thing they did on Mars, was they went and they looked for water to see if they had found water. That would indicate that life may have existed on Mars at one point. So water is the molecule that enabled life to exist on Earth. Number 10 is asking, why does a water molecule cling to glass? And the reason why is because you have a positive side and a negative side. The sides of the glass is made of silicon. Silicon is going to have a positive charge to it. It's going to want electrons. And so the oxygen side here, the oxygen, has a negative charge, and so it is attracted to the walls, the positive silicon glass, and so that's why you get the meniscus, the kind of the little lip that exists on the sides of a glass, and also why. But that's what causes that. That was number 11, or no, that was number 10. Number 11, why does a water molecule take more energy to heat up and cool down? And the reason why is anytime you have bonds require, they release energy when they break, and it takes energy to make bonds. So energy takes a lot. If you're trying to heat water up, you're going to, it's going to take extra energy because you have, I should back up there a little bit. Water, okay, you can see here has a negative side and a positive side. This positive side is attracted to the negative of another water molecule. It's attracted to the negative side of another water molecule. So what ends up happening is you have these, what they're called hydrogen bonds, between the negative side of the water and the positive side of the hydrogen. And these bonds are not, they're not technically sharing. They're not technically the bonds that are the hydrogen and oxygen bonds that exist just between hydrogen, oxygen, and water. They're just kind of a weaker bond between the positive side of the hydrogen and the negative oxygen. And so these bonds, again, in order to heat the water up, it takes more energy to break these bonds, heating the water up. And then in order to cool it, it's harder to cool the water because it's harder. Their water has to make more bonds in order to cool down. So that is the kind of the different questions from today, and hopefully you can answer those.